All right, moving on to lenses. It's pretty similar to mirrors, except opposite. You'll see how that works in a couple ways. First off, so we're going to look at how converging, which notice before with mirrors, converging was concave, but for lenses, converging is convex. We'll see why that is in just a second. And then diverging are your concave mirrors. So we're going to look at how they focus light from infinity real quick. When we do that, we're going to take a ray. We're going to aim off from infinity just like before, so it should be parallel to our principal axis. Notice I've already drawn them in here. Now, if we wanted to get into the refraction here, it's going to bend towards the normal, which is going to bend it down, which is why this one is going to this one's going to converge the rays, whereas down here with our diverging lens, it's going to bend them up because that would be towards the normal, whereas here this is towards the normal. But the way you do it to simulate that bending, just go straight to the middle point, and then after you're there, come out and aim at the focus on the far side. So I always think of this one as the way it naturally feels, because you want to aim for the focus in the direction you're already going. So I'll just do a couple more rays here just so you can get the idea. I'll do 3. Come through, go up through the focus on the far side. As a result, we call it a positive focus if it's on the opposite side of the object. So in this case, we would have a positive focus. Here's my last ray. Notice they are all going together, thus making this a converging lens. Very cool. Whereas down here with the diverging lens, here are my focal points. We're going to use the opposite focus of what feels natural. And this is one of the ones where people always get confused. Just remember you're using a negative focus on this one, so you should be using the one opposite. So I naturally feel like I should use that focus. So what I'm going to do is I'm going to aim at this focus back here, and then I'm going to draw my ray off. I can do my dotted lines backwards, whereas if I'm not having them come in from infinity, I'll be able to figure out where my virtual image location is, but since it's showing up at the focus, we shouldn't get one. Aim backwards at that focus. Continue on out. Dotted lines back. Almost lost it there. And then finally, one last ray. And ray goes off. Dotted lines come back. Notice how these rays all spread out, diverging, and these rays come together, converging. Now from that, we should notice that basically we have the exact same formula for your focal length with object and image distance as we did with the mirrors. Same for magnification too. The only difference now is when things are positive and when they're negative. So looking first here, our focal length is positive when we have a converging lens. So that's going to be our convex lens. And we'll have negative when it is concave. When is our object distance positive? Again, that's always positive. We'll never make it negative because definitionally we'll put it on the positive side. The side the object's on is the positive side. Your image distance, just like before, if it's positive, it's going to be real, and that's going to be on the opposite side of your object, and it'll be virtual if it's negative, which is the same side as the object. For magnification, just like before, if you have a positive magnification, it's going to be upright, and a negative magnification is virtual, is inverted. Started reading what was above it. For your object height, it's always going to be positive because we're going to define the side of the principal axis the object is on as positive, and so it'll never be that. If your image height is positive, then you have a virtual upright image. You can figure both of those out from that. And then if it's inverted, if it's negative, you get your inverted and real images.